So KB is a little bit different because we have our generic base reacts with water to form our conjugate acid and hydroxide. So our KB is actually the conjugate acid times hydroxide all over the concentration of our base. So even though we have pH, right, we eventually need to find hydroxide because hydronium doesn't show up in this equilibrium. So there are many ways you can solve this. I would simply say, okay, pH plus POH equals 14, and I would find my POH. So POH equals 14 minus 12.2. So that means my POH equals 1.8. So now that I know POH, right, I need to find hydroxide. Hydroxide is 10 to the negative POH. So hydroxide is 10 to the negative 1.8. So 10 negative 1.8. So my hydroxide concentration, 1.58 times 10 to the minus 2. That also equals, right, the concentration of my conjugate acid, right? They are formed in the same 1-to-1 ratio. So now I know my concentration of hydroxide, conjugate acid, and I know my initial concentration of the base was 0.5. So KB equals 1.58 times 10 to the minus 2. 1.58 times 10 to the minus 2 all over 0.5. So I'm going to square that and then divide by 0.5. And I get a KB of like 5. Well, 5 times 10 to the negative 4. Now the question is how many significant figures they're looking for, right? And so, okay, this is set at 2 significant figures. You're sure your pH only said 12.2? There wasn't anything else?
Minus 1.220 e to the 1.
1.220. So yeah, that 0 is important, right? So that now I'm in agreement with, there should be 2 significant figures for our KB. Yours as well, if it said 0.21, like if it was 12.21. Gary, we went over this before and we found out that it was your mistake. The last time we went down this road, there was a mistake. Is this working for you?
Yeah.
Okay. All right. At least it works for one person. It worked for Alekia. We're just going to blame this one on Gary. Gary's going to take the L here for us.